Quantum Mechanics Overview. Subscribe. Universal Tutor. Quantum mechanics, often simply called quantum physics, is the branch of physics that deals with the very small. While classical mechanics describes the physical properties and behavior of macroscopic objects, things much larger than atoms and molecules, quantum mechanics describes the physical properties and behavior of the microscopic and submicroscopic realms, especially atoms, molecules, and fundamental particles like electrons, protons, and photons. Here's an overview of quantum mechanics. Wave-particle duality. At the quantum level, particles like electrons don't behave strictly as particles or waves. Instead, they exhibit characteristics of both. For example, electrons can create interference patterns, a wave phenomenon, but can also be localized as particles. Quantization. Many properties in the quantum world are quantized, meaning they can only take on certain discrete values. A well-known example is the quantization of energy levels in an atom. Superposition. Quantum systems can exist in a combination of multiple states simultaneously. It's only when a measurement is made that the system collapses into one of the possible outcomes. The famous thought experiment of Schrödinger's cat, which posits a cat that is both alive and dead until observed, exemplifies this concept. Entanglement. Two or more particles can become entangled in such a way that the state of one particle immediately affects the state of the other, regardless of the distance separating them. Einstein famously referred to this as spooky action at a distance. Probability. Quantum mechanics is inherently probabilistic. Instead of giving definite outcomes, it only provides probabilities of different outcomes. The wave function, often represented by the Greek letter psi, gives information about these probabilities. Heisenberg's uncertainty principle. There are limits to how precisely certain pairs of properties, like position and momentum, of a particle can be simultaneously known. The more precisely one property is known, the less precisely the other can be known. Pauli's exclusion principle. No two electrons in an atom can have the same set of quantum numbers. This principle explains why electrons fill atomic orbitals in a particular manner. Standard model of particle physics. This is the current theoretical framework describing the electromagnetic, weak, and strong nuclear forces and the fundamental particles that make up the universe. It's based on quantum field theory, an extension of quantum mechanics. Applications. Quantum mechanics is fundamental to a wide range of modern technologies. Semiconductors, and by extension, computers and smartphones, lasers, MRI scanners, and many other technologies are based on principles of quantum physics. Interpretations. There are several interpretations of quantum mechanics that try to explain its counterintuitive nature, such as the Copenhagen interpretation, the many worlds interpretation, and the pilot wave theory, among others. In essence, quantum mechanics challenges our classical intuitions about the nature of reality. Despite its apparent strangeness, it's one of the most successful and tested theories in the history of science, with predictions confirmed to incredible degrees of accuracy. However, it also remains a vibrant field of research with many unanswered questions, particularly when trying to reconcile it with general relativity in the search for a complete theory of everything. Thank you for watching. Please subscribe and like.